Good afternoon, sir.
Yeah, like I said, I'm sorry I was having some few network issues. That's why it late. So last week we met. Those of you who are not around last week, my name is Dr. Agbeko, and I'm taking you for the mobile application programming course. I hope your friends have told you a little bit about me. But let's go on. As we go on, you get to know me the more. Last week we introduced ourselves to the mobile application development course, but because we are talking about mobile applications, we needed to look at some of the devices that our application that will be developed will be working on. So last week we concentrated more on the mobile app devices and some mobile application protocols. Now, at the end of last week, I asked if you have a deep idea about programming because what we are coming to do is more of programming stuff. And from the little I know, I got from you guys, I could see that I need to prep you before we enter into the programming itself. So today I decided, and I promised last week, I decided that today we'll be looking at some few programming fundamentals so that I'll prep you, I'll remind you of some of the concepts you already know. And those who don't know about programming, we'll discuss it before we start the mobile app development programming. So today, basically, we are prepping ourselves again on some of the programming fundamentals you might have already known, so that we can go on from there. So our objective today is to know why we need to create programs or software or applications. So we'll see why we need to create programs, softwares or applications. And then we'll look at programs and their programming languages. Then we'll look at various tools for problem solving. We'll look at variables, we'll look at operators, we'll look at decisions, and then we'll look at repetition. These are the fundamental knowledge that a programmer need to add before he goes on and they start programming or developing a software. These are the fundamental knowledge that a programmer needs to have before he goes on to develop a software. So knowledge about variables, knowledge about operators, knowledge about decisions, and knowledge about repetitions. Now, we know what a computer is. We said the computer is an electronic device that accept data, processes the data, and give out information. So when you are using a computer, we have what you call the input process output cycle. The input process output cycle. Now, please, if you have any question, you can just raise your hand and I'll call you to ask a question. Okay. So anytime you're using any computing device, you should have at the back of your mind that part of the activities that you'll be performing on the device is input. You are inputting data. You are inputting signal. Part of the activity that the device will be performing is processing. It is processing your input and then to give you what? An output. That is what we call the IPO cycle. Any computing device, be it a mainframe, a super frame, a mini computer, a laptop, a desktop, a mobile app, a mobile phone, a tablet, an iPhone, whatever it is. When you are using it, we have the IPO cycle. Some of the actions you may be performing are input actions. Some will be processing action that the device itself will be performing, and some will be output actions from the device. So as I said, therefore we have what you call the input process output cycle. Every programmer must know this. The cycle of activities performed by a computer is referred to as the input process output cycle. Each component of a computer participates in either one of these. So as you are using your computer, it can be a mobile phone, it can be a tablet, it can be a laptop, whatever computing device that you have. You are performing one of these things. You, the user, will be inputting in data or signal. The device will be performing some processes that will give you what? Output. So we said the computer is designed to accept input. That is, anything from outside the computer system that goes into the computer system is what we call input. Process the input and generate output. Now, for the computer to accept input, process the input and generate output, you need to instruct the computer to do that. And these instructions that help the computer to perform its work is what we call a program, a software, or an application. So for the computer to work, it needs an application, a software, or a program. The three words are synonymous. An application the same as a software or a program. For the computer to work, you need to instruct it to perform its work. For the computing device to work, for the mobile phone to work, for the tablet to work, for whatever computing device you are having, for it to work, you need to instruct it to perform its action. And these instructions is what you call an application or a program or a software. So as what we are coming to do this semester is basically writing programs or application or instruction for our mobile devices to work on, especially mobile phones. That is the essence of this course. We are going to learn how to write instructions which the mobile phones will be using. That's why we call it what? Mobile application programs. Programming. Mobile application programming. Instruction in a program or instruction in a software can be sequential, decision-making, or iterative. So it means that basically the computer executes this instruction in a sequential manner, just as we read our note from top to down, left to right, line by line. That is what we mean by what? Instruction, how the computer executes this instruction. So when you are writing a program, the first you should know that you have to write it in a sequential order, line by line, from top to down. Then we have decision making. Sometimes you ask the computer to execute a set of instructions or part of the program by taking certain decisions. We call it selection. We'll come there today. I will explain it today. Okay, so the computer is not just executing your instruction from top to bottom. But please, this set of instructions here, please, if you want to execute it, then evaluate this condition. And if the condition is true, then execute. If the condition is not true, then you don't execute. So that's what we mean by decision making. The instruction may have decision making construct in them, asking the computer that, hey, if you want to execute this, then take this decision for me. For example, you are writing a set of instructions to the computer to calculate discount. And you know, for you to give somebody a discount, it means that certain condition must be met. If the price of the item is above a certain amount, then give the discount. If it is below the amount, don't give the discount. So such a situation, you ask the computer to execute or make decision for you. So in your programs, you have decision-making construct. And then we also have iterative construct. We also have an iterative construct where you ask the computer to repeat a set of instructions for you. Just like the normal human being will repeat certain actions for a period of time. In the same way, sometimes you ask the computer that this program repeat it severally. For example, I can see you are about 15 or 16 there. If I am writing a program to accept your student ID, your student details, it doesn't mean that I should write 16 different programs. I will just write one, but I'll add the program to repeat itself. That's what you call iterative construct. So you can also ask an application to repeat itself. Please, are you here with me?
Yes, sir.
Okay,
Yes, sir.
so remember, the instructions that we write for the computer, one, they are in a sequential order from top to bottom. Two, you can ask them to take certain decisions based on evaluation of certain conditions. And three, you can ask them to repeat several times also based on evaluation of what certain decisions. Now, I just mentioned the difference between an application and a program. I said that a set of instructions is called a program. Now, when this program or software is providing certain services, then we call it an application. So the set of instruction or program providing certain services, then we call it an application. So the instruction being executed, the user is using it to provide, to enjoy certain service, then that thing becomes an application. For example, if you go on the website to download, to do downloading of whatever, a textbook, whatever you download, the website is an application. It is enable you to enjoy the downloading service. The website is an application. That website is a set of instructions that has been written and hosted, and it's enable you to what? To enjoy the application, the downloading service. So an application is basically a program which is enable you to what? To enjoy a service on a computing device. Now, for you to write a program, the person who writes a program is called a programmer. Okay, a person who writes a set of instructions for the computer to execute is known as a computer programmer. But remember, we talk about a set of instructions. So it means that you must instruct the computer in a language it understands. Once we're talking about instruction, the language comes in. I'm speaking to you in a language you understand. So, or if I instruct you, I must instruct you in a language you understand. If, for example, you don't understand English, but you understand French, it means I must instruct you in the French language. In the same way, when we are writing computer programs, we write the program, the instruction in the language that the computer understands. Are you here with me?
Yes, sir.
Hello?
Yes, sir.
Yes, so we write the instructions in the language that the computer understands. And these are what you call programming languages. So a programming language is just a language that has been developed through which computer programmers write computer programs or give computer the set of instructions. Now take note, all programming languages by themselves are also software. They are programs. Somebody developed them. All programming languages are by themselves softwares. Somebody developed them, so they are programs. But they enable you to what? To develop other softwares. They enable you to develop other softwares. Now, we have different categories of programming languages. Okay, so to start with, we have what you call the machine language. The machine language is basically what the computer actually understands. The computer is an electronic device, so all it understands is electricity. Off and on, off and on. So for us to be able to manipulate this electricity, we came out with the machine language, which is made up of bits, zeros and ones. So the computer basic language is bit, zeros and ones. Okay, but to make programming easier, we've developed what you know as high-level programming language with English statement. Example is the C++, the Visual Basic, the Java, and then the mobile app, the Flutter, and the what? That programming language you'll be learning. So these high-level programming languages are written using English words, but the computer does not understand English. What the computer understands is bit, zeros and ones, because it is an electronic device. Meanwhile, you will be writing your language, your program in a high level now, because you cannot write in zeros and ones. You don't understand electricity. So what we do is that we have developed a program known as the compiler. So programming languages have their compilers. C++ has its compiler. Java has its compiler. That have its compiler. You'll be looking at the one we'll be using from next week. Programming languages have their compilers, which enables you to translate whatever instructions you have written in the English code to the zeros and ones that the computer understands. Formerly, we were writing the program using the zeros and ones. So whatever you want the computer to do, you instruct it using the zeros and ones. But it was difficult. So we developed these high-level programming languages and attached compilers to them. So C++ has its compiler, C has its compiler, Java has its compiler, Visual Basic has its compiler. All current programming languages have their compilers. And what the compilers is that after you have written the program in these high-level languages, then the compilers translate the programs into the machine language and call the computer to what? To execute. Next week, I'll show you the compiler we'll be using for our mobile app development course. Now, please, are you here with me? Any questions so far? Any question? Any questions so far? Hello?
No, sir.
Any question?
No, sir.
Not yet.
So do you understand that answer so far?
Yes, sir.
Are you sure? Are you talking for yourself? Please, who is talking?
It's Emmanuel.
Who?
Emmanuel.
Emmanuel, you've understood what you said so far. What about the rest? Please, the rest. Are you getting what you are doing?
Yes,
The
sir.
explanations of what you are doing.
Yes,
Yes,
sir.
Okay, so remember, for you to write a set of instructions for the computer to execute, you need a language, which we call programming language. Let's go on. Now, the programs that you write, every computer program within using any programming language is basically made up of two parts. And please, from here going, I want you to listen very well. Every computer program, no matter the programming language, it can be Java, it can be C++, it can be Visual Basic, whatever. It's basically made up of two parts. We have what you call the operation code and then what you call the operand or address. We have the operation and then we have the operand. Or we have the code and then we have the address. Let me explain. You see, let me use this scenario. Is Ariam there? Ariam,
Yes.
are you there?
Yes, sir. Please, I'm here.
Ariam, can you tell us the step-by-step, if assuming you want to prepare rice, you want to cook rice, okay? What is the step-by-step way of cooking the rice? Can you share with us?
Okay. So we'll boil water. We'll put water on fire, make it come to a boil. Then we'll wash the rice.
Take your time. You are going too fast. Where do you put the water? Do you pour the water on the fire?
No, please. We put it in a silver or a pot.
Okay, so you put it in a silver or a pot or a rice cooker.
Then when the water comes to a boil, you add the rice.
So when the water starts boiling, you add the rice, right?
Yes, sir.
So basically, then you add salt, okay?
Yeah.
Go on, I'm listening. We are listening.
So then you allow it to cook.
Okay. So, Elia, for what you have said, it means that there's no way we can cook or boil something without a saucepan. True or false? All of you, true or false?
True.
True.
You cannot cook without a saucepan. You need a holder, a saucepan, a container of the food, right?
Yes, sir.
That is why. And two, you need to perform something on the inside the container or something on the food inside the container. True or false?
True.
So let's take the cooking of the rice, for example. We need a saucepan to hold the rice with water, and then we perform certain things on the rice. we add salt to it, we put it on the sauce fire, we stir it, and then we do series of activities on the rice inside the saucepan, right?
Yes, sir.
Okay. It's the same thing when we are writing computer program. The rice that you are cooking is your data. The rice that you are cooking is the data that you have entered into the computer system. That data must be in its saucepan called the address. Must be in its saucepan called the address. And then you must perform certain activities on the data called the operation. Are you here with me?
Yes, sir.
Guys, are you getting the scenario?
Yes, sir.
Yes, sir.
Okay, so we are cooking. I'm cooking with you. We need the saucepan. We need the rice. We need to perform certain things on the rice in the saucepan. What you perform on the rice in the saucepan is what you call the operation code. The rice is the data. The computer accepts data. And the saucepan is the memory space where the data will be. So we say the operation code, this part instructs the computer about the operations to be performed. The activities that you are performing on the data is what is called operation code. That is the instruction. That is the algorithm. And then the data should be in a container, in the saucepan, in the computer memory. That is the address. So we say the operand, this part instructs the computer about the location of the data on which the operation specified is to be performed. So when we go to the next slide, you see it. Every computer program is made up of two things. A place where the data can be found, and then the instruction that you need to do on the data. Are we okay? Let's go on, it will come. Let's go on, it will come. So this brings us to the topic of algorithm. This brings us to what you know. I quickly want to discuss algorithm. Remember that from our previous slide, I've gone back. We are saying that every computer instruction, you need to instruct it. You said a programming language, you said that. But every computer instruction is supposed to be made up of two parts. The first part should hold the data you are performing something on. The computer accepts data. So where can the data be found to be worked on? That is the operand or the address, the location. We look at it, the memory space where data should be put. We call it variables. We look at variables very soon. And then what you are doing on the data. So what you are doing on the data brings us to this topic known as algorithm. I hope you've met the topic before, algorithm. Have you met it before? Please, have you met the word algorithm before?
Yes, sir.
Sir.
Yes or no?
Yes,
Yes,
sir.
sir.
Yes,
So
sir.
what is an algorithm? If you met it before, what is your idea of what an algorithm is? What is your idea? Who can tell me of what an algorithm is? What's an algorithm? Yes, I'm listening to my people. Hey, am I there? You are the only female, so I'll be worrying you.
There's an instruction set to solve a problem.
An instruction that is used to solve a problem. Very good. You also have something to say. Please, who just spoke? Who just spoke?
Justice.
Justice, you are right, but who also has something to say? Justice, you are perfect. It's a set of instructions that is used to solve a problem. Very good. Then,
Sir.
who also has something to say? Yes.
Sir, there are steps,
Step by
step by
step.
step
Okay.
set of instructions used to solve a specific problem.
Okay, we are all right. So algorithms It's a sequence of steps required to solve a problem. So all of you are correct. Okay. Now, I want you to take note of this. Every piece of computer program that you write is supposed to solve a problem. We create softwares, applications to solve problems. Are you here with me?
Yes,
Are
sir.
you here with me?
Yes, sir.
Yes, sir.
Yes, sir.
Every software that you are using, or every program that you are using, or every application that you are using is supposed to solve a problem. And the way we solve the problem is to study the application and find the step-to-step solution to the problem. And the step-to-step solution to a problem is what we call algorithm. So algorithm is the sequence of steps that are taken to solve a problem. This sequence of steps can be written in English or any other language. Okay, so you don't just stand up to write computer programs. No, we don't do that. It's just like the architect will not just stand up and start building a house. No. We have series of activities that we do to come out with the computer program. We have to write the steps, the solution on paper, and then we look at it and develop the computer program. Now we have two levels of algorithms. We have what you call the micro level and the micro level, the macro level and the micro level. So let's come back again. Ayam, are you there?
Yes, sir.
Ayam, where do you stay?
Please, I'm in Ho.
You are in Ho? Okay.
Yes.
So if I want to come to Ho, give me the step-by-step way of reaching you at Ho.
You go to the station and pick Hoka.
Okay, I go to the station, pick Hoka, go on, and then what happens?
Then you enter and they'll bring you.
Okay, so I go to a station, pick Hoka, enter, and it drives me to Ho, okay? No, I'm teaching. Please, are you here with me? Are you all here with me?
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
so Abraham has given us what to call a macro, MA, algorithm. Brief algorithm. If you want to go to a station, pick a car. Step 1, move from your house to the station. Step 2, pick a car. Step 3, it will drive you to home. Step 4, you got it to home. Step 5, call me. So that is macro, brief. MA, micro level algorithm. But Abraham, can we go on with our discussion?
Okay.
Which station should I go to?
Sir, please, it depends on where you stay. So you have to do Medina. So anyone close to you, you
Okay.
can go there.
So you see, what you did first, the things you said first, are the macro, brief. But now I want you to go to the details. So if you want to step 1, if you want to come to me, go to the major station near you. So if you're in Adenta, then maybe you move to Medina. And 2, you take whole car. Please, the whole car, there are different type of car that comes to home. Maybe air conditioned cars and what? Non-air conditioned car. This is how much air conditioned car costs. This is how much non-air conditioned car costs. So you see now, you are giving me details of what to do, right? Then step 3, please, on the way to home, for you to make sure that you are home, be asking of the times you'll be getting to, so that you can get to Adomi. Where you see the Adomi bridge, you can get to Japan, you can get to Chito. Are you getting what I'm saying?
Yes, sir.
So you see that now I'm giving you detailed description of how to get to home. That even if the person have not gone to home before, he can follow this teaching and get to home without being lost. But what you did at first, you gave me brief description. Those brief description is what you call macro algorithm, and the detailed one is what you call micro level algorithm. Are you here?
Yes, sir.
Are you here with me?
Yes, sir.
Guys, are you here with me?
Yes, sir.
Yes, sir.
So if you are writing computer programs, you must take your time. We need detailed algorithm. Detailed. I have been telling my students that if you don't have time and patience, you cannot learn programming. You cannot become a computer programmer. Meanwhile, that is where the money is. That is where the money is. You need to take your time and write the program and test the program and do all that you can for the program to run well. Detailed algorithm, micro level algorithm. Okay. Now, for us to be able to write programs well, we represent this algorithm using what we call flowchart and pseudocode. And I know that for flowcharting, I hope all of you know what a flowchart is. Hello? Hello? Are you there?
Yes, we
Yes,
are
sir. We are
here.
here.
You all know what a flowchart is? Yes or no?
No.
Hey, my people, you don't know what a flowchart is?
You know.
Okay.
Yes, sir.
You don't know what a flowchart is? Okay. So, for we programmers, we talk about algorithm, the step-by-step way of what? Solving a problem. And we say we have for detailed algorithm and then we have for brief algorithm. Brief steps. A, B, C, D. Do A, do B, do C, do D, and then you are done with the algorithm. And then we have the detailed one. Do A, B, C, D, E, F, G, H to give you detail way of solving the problem. But we must find a way of writing the algorithm, representing the logic, writing it down before we start writing the computer program. So to represent the algorithm, we use what we call pseudocode or what? Flowchart. So we have the pseudocode and then we have what? Flowchart. Now, let's take pseudocode. A pseudocode is a detailed description of an algorithm written in a language which is not a programming language. Which is not a programming language. So you are writing the detailed description of the algorithm. You are writing the algorithm down, normally using some English keywords. That's what we call pseudocode. So you are writing the algorithm like you are saying, if I want to get to O, okay, step 1, move from where you are to a station near you. Step 2, pick whole-banded car. There are 2 types of whole-banded car. Pick the one that you want. Step 3, when the car moves, start asking for these major towns. Step 4, if you get to Soko there, you are near to Ho. Step 5, this one, you are using English keywords to represent your algorithm. And this is what we call pseudocode. So pseudocode is then the representation of an algorithm in a language which is not a programming language yet. And these are the keywords you may use when you are writing pseudocode. We will come to these keywords. Can you see the screen?
Yes,
Slide
sir. We
number
can.
15. I was slide number 15. Can you see the screen?
Yes,
Yeah.
sir.
So you see that I'm showing you the keywords there. These are the keywords for pseudocode. And I will explain as we come back. I will explain as we come back. So pseudocode are written algorithms, let's say in English, which are not yet written in a program by using a programming language. Pseudocode provides programmers with detailed template for writing instructions to solve a computer problem. So once you have written the pseudocode, a computer programmer will just look at the pseudocode and will start writing the instruction in a programming language. So for we programmers, we take pseudocode and then we look at it and we start writing the instruction in the programming language. So we have the advantages of pseudocoding and then we have the disadvantage. I'll give you these slides to read. Now let's go to flowchart. Another way of representing an algorithm is flowchart. Flowchart. Flowchart is a graphical representation of an algorithm. Okay, so the step-by-step way of solving the problem. You can draw, you have certain symbols that you can use to draw these step-by-step ways of solving an algorithm. We call it what? Flowchart. You are not writing the steps in the language, in English, but you are drawing it using symbols, graphs, symbols, okay, diagrams. It's a diagrammatic representation of an algorithm. So flowchart consists of what? A set of what? Symbols. And please, I'll show you. I don't have the symbols here, but just let me show you something. I'll show you. Let me share this screen with you. I'll come back to flowchart. Let me share this screen with you. Let me share this screen with you. I'll come back to flowchart. Let me share this screen with you. When you go to Microsoft Word, okay, just a minute. Just a few minutes. I'm sharing Microsoft. I'll show you the flowchart symbols. So look at this. Are you here with me? Now look at this symbol here. I hope you can see my screen.
Yes, sir, but it's
Yes, sir.
blank.
Oh, you can't see Microsoft Word. Yeah, I'm not typing it. I'm showing you some symbols.
Okay.
I'll share it again. Can you see what I'm doing? Is my mouse moving on your screen?
Yes, sir.
Can you see my mouse? Is it moving?
Yeah.
I've clicked on Microsoft Word. Has it opened Microsoft Word?
Yes, we can see.
Except the mouse.
You can see what I'm doing, right?
Yes, sir.
Yes.
I've gone to shapes. Can you see the different type of shapes?
Yes,
Yes.
sir.
Look down there, you see flowchart. Have you seen where my mouse is? Flowchart. Have you seen it?
Yes.
Yes, sir.
So you see the different type of symbols there.
Yeah.
That's what you use for flowcharting.
Mm.
Each of them means something. So you see the rectangle. Can you see flowchart process? Has it appear?
Yes, sir.
Yes.
Then the next symbol, we say what? Flowchart alternative process. Then we have the decision, flowchart decision. Can you see when I put the mouse is the mouse on it, the name count, can you see?
Yes, sir.
Yes.
Then we have flowchart, data input, right?
Yeah.
Yeah.
So these are the flowchart symbols that we use to create flowchart. For example, the last symbol there, you see flowchart, display, output. I hope you can see.
Yes.
So these symbols are used to represent an algorithm in a diagrammatic form, using a diagram. So that you don't write it in English, but you draw a diagram for it. Okay, and before we go, I'll show you sample flowchart. I'll show you sample flowchart. Let's go on with what we are doing. I'll show you sample flowchart. Okay, so we are here. So as I was saying, flowchart are used to also represent algorithm. Remember, I've said that we have pseudocode. We use pseudocode to represent algorithm, and then we have flowchart. You look at the advantages and the disadvantages as we go on. Let's move on. Now, few minutes ago, I was talking about saucepans. Okay, do you remember I was talking about the cooking pot or the saucepan? Are you here with me?
Yes, sir.
Yes, sir.
And what did I say the saucepan does? When Ada was cooking for us, what did you use the saucepan to do? Ada, when you were
So
cooking, what did you use the saucepan to do?
To
it's
contain the
a container to hold the substance, the food inside.
That we are cooking, right?
Yes, sir.
Okay, so this brings us to the topic of variables. This brings us to the topic of variables.
Okay.
As a programmer, you cannot program without meeting the right variables. In fact, variables will be one of the first things you must learn when we come to programming, variables. Just like I said, the saucepan holds the food you are cooking. It's the same thing. Variables hold the data you are processing. We write computer programs to process data into information. So variables are memory spaces that hold the data you want to process. They are the saucepans for the data, but they are not physical saucepan. They are located in the memory. So the internal memory consists of different locations in which data is stored. A computer needs to identify the location, the memory location, to be able to retrieve values from or store values in them. You cannot process data into variable without the memory location. And with memory, we are talking about RAM, the random access memory. The random access memory. If you want to program, then you must know that you are going to use the random access memory to hold the data that is you are going to process. So variables refer to the memory location whose value changes during the program execution. They are memory location that holds the data you are processing. We have two types of this data. We have variable data and then we have constant data. A constant refers to memory location whose value does not change during program execution. So for example, if I am creating a program to accept certain values and then calculate VAT on an amount bought. Hello? I'm going to calculate VAT. You know that the percentage of VAT, 17.5%, does not change. That 17.5% will be a constant because it does not change. Let me give you another example. If I'm to create a program to calculate the area of or the circumference of a circle, I'm creating a program to calculate the area or circumference of a circle. Then the pi is a constant, 3.14. It's a constant value that will not change. But the radius will change depending on how big the circle is. I hope you are getting me. Are you here with me?
Yes, sir.
So in this case, the values, the radius whose value will change, will be put into a variable, and then the pi will be put into what? A constant. You need memory location to be able to process data. And this location are what we refer to as what? Variables or what? Constant. Now, look at this diagram here. Let's look at this diagram. So look at this diagram. This is how, have you seen slide number 17? I'm on slide number 17. Can you see it?
Yes, sir.
Okay. So you see that in the computer system, we have memory spaces. The memory spaces are those in white, where we have the number 10, 50, and 25. These are the memory spaces. Now, the number in front, on top of them, 4560 for the placeholder 10, memory space 10, 4562 for memory space 15, and then 4565 for the placeholder 25 are memory addresses that the operating system gives to the memory. So you see, address of memory location. These ones are given by the operating system. The 10, the 15, and 25 are the data in the memory. So that is what the user is going to put into the memory spaces. And then the num1, num2, and the sum are the names we programmers give to the memory space. Every memory space that you need to use, you must give it a name. So num1 is the name that a programmer has given to the memory space that is holding the number 10. Num2 is the name that a programmer has given to the memory space that is holding number 15. And num3 and nsum is the name that is given to the programmer in a space that is holding the number 25. Please, those numbers at the top are the address of the memory given by the operating system. The names down there, num1, num2, and nsum, are the address given by the programmer. The white spaces are the memory spaces, and then the 10, 50, and 25 are data values stored in them. Any question? So this is what we mean by variables. Any questions? Hello? Any question?
Sir,
Yes
sir,
or no? Yes.
please, the memory location, is it the same as the where the value is stored?
Yes,
they
the memory location is where the value is stored.
Okay.
And that is RAM. You don't physically see RAM, but it is there, the random access memory. Remember that you were introduced to random access memory when you started secondary school, computer, introduction to computer, IT. Remember, you've met the word before, right?
Yes, sir.
The random access memory. That's the memory location you are talking about. So that is where the data value is stored. Any other question? So your number 10 is in one memory location. The number 15 is in another memory location. And the 25 is in another memory location. Another question. Any other question before I go on? I want you people to understand this concept very well. Any other question? Guys, please ask your questions. So, I'm listening, ask your questions. Yes. Emmanuel, are you there?
Yes, sir.
Any question for me?
Not at the moment.
So you understand what we are doing?
Yes, sir.
Steven, are you there?
Yes, sir.
Any question for me?
Not yet.
Hey, so when? See, not yet. So when?
As we move on, the question will come.
Okay, let me see if I have the ideas here. I can mention their names. So I'll mention Steven's name. Adams, are you there? Adams.
Sir, please, Adams.
Any question for me?
Sir, please, Adam says he has a problem with his speaker, so you can't hear him.
You can't hear me.
Yeah. No,
okay,
you
Brown,
can't.
Nobel.
Sir.
Nobel, can you hear me?
Yes, please.
Any question for me?
No, please.
Sorry, Desmond. Desmond, can you hear me?
Yes, sir.
Any question on variables for me? Because you must understand this concept very, very well. Any question on variables for me?
Not yet.
Okay, Elvis.
Yes, sir.
Elvis, any question for me?
No, sir. No question.
Are you okay with all that we are saying so far?
Yes.
Yes, sir.
Emmanuel,
Yes, sir. You've asked me already, so.
okay, so what about Kwame, George?
Yes, sir. I'm okay
George,
for now.
you're
I'm
okay,
okay for
okay,
now. Yeah, when the question
okay,
comes up, we'll let you know.
okay, thank you, thank you. So let's go on, guys, let's go on, let's go on, let's go on, let's go on.
They didn't
Let's
mention
go.
my name.
Yeah, please, then ask me your question, sorry.
I don't have a question.
I know you say you don't have a question, so anyway, let's go on. Can we box on? So please, for you programmers, or if you want to become a programmer, then this concept of variables, you should know it very well. Because there's no way you can write computer instruction without meeting the word variables. They are the memory locations where data is put for processing. Okay, let's go on. Now, if you are using variables, the memory locations, then you must indicate the type of data that should be in the variable. I want you to listen very well. So this brings us to another important topic, data types. The computer data type. The computer accepts data. So what type of data is going to be processed? You must indicate it. Now, Aram, are you there? Today I'm teaching with you. Madam, are you there?
Yes, sir. Yes, sir. Please, I'm here.
Aram, if you know what that the sign is?
Pardon?
That the sign, have you
Yes.
heard the word before?
Yes, sir.
So if I ask you to bring me that the sign, what comes into your mind?
Pots.
Pot, okay. And what do we use normally? What do we use such a pot for?
So in my mind, I know food is going to be
In your
cooked.
mind, what are you using it for?
We are going to use it to prepare something.
What type of food?
Banku.
Banku
Yes.
or kokunte. So
Yes.
once you say the pot, we all know that you are preparing the type of food you are going to prepare is what? Banku, right?
Yes, sir.
Guys, are you there?
Yes, we are here.
Yes, sir.
So wardrobe, you know what wardrobe is, right?
Yes, sir.
What is it used for?
For pounding. Oh,
For pounding fufu.
yeah.
So wardrobe is the mortar. So when we say
Oh,
wardrobe, remember that it's a container. It contains the cassava you are pounding in it. So once we say wardrobe, you know the type of food you are coming to cook. If you say rice cooker, you know the type of food you are coming to cook. If you say fry pan, you know the type of food you are coming to cook. In the same way, the memory locations that you are going to customize, you must tell us the type of data that are going to be in it. So this brings us to the issues of data types. The computer system understands two main categories of data, two main types of data. We have numeric data that is processed, and then we have text data that is processed. Please, I want you to listen very well. The computer understands two main types of data, or there are two types of data that the computer accepts and processes. Numeric data and what? And the text, or what you call character data. So if you are declaring your variables, you declare your variables, the memory space, to either hold numbers or text, characters. Okay, for example, if I am creating a computer to calculate the area of a circle, then my variables will be the data the type of data I will accept into those variables are numbers. We don't use text to calculate areas. Are numbers. But if I want to create a program to accept names of, what do you call it? Names of shapes, then the data type will be text, because I'm talking about what? Names. So we have text data, or what we know as character data, and then we have what? Numeric data. Please take note of this. The numeric data types are, or numeric data are the type of data that you can perform your basic arithmetic operations on. So any data you can add something to, any data you can subtract something from, any data you can multiply with something, any data you can divide with something or find a remainder, then you will use numeric data types. If you use numeric data types, it means that you are performing arithmetic operation on the data. You want to perform an arithmetic operation on the data, numeric data type. But if you use character data type, it means that you are talking about normal letters, numbers, and special characters. Are you there with me?
Yes, sir. We are here.
So now my question, the whole class should answer this. If I am creating a variable to accept phone numbers, what type of data should the variable contain? Numeric or text?
Numeric.
Who is talking?
The Prince.
Yeah, please, the question again.
Okay, if I'm creating a variable to hold phone numbers, phone, your phone number. If I'm creating a variable to hold phone numbers, that variable, what type of data should contain it? Is it a numeric data or a text data, character data?
A numeric.
Okay, yeah, what do you say?
Numeric.
Yeah, the next person. Where are they? The next person, what do you say?
Numeric.
Adam said numeric. Let's go on. Yes.
Numeric.
I'm coming. Where are the participants? Just a minute. So let me make sure your name there. You tell me. Area says numeric. George, is it numeric or text? George. Emmanuel.
Numeric.
Numeric. Justice.
Yeah, numeric.
Justice.
Yeah,
Numeric.
numeric.
Prince.
The numeric.
Okay, very good. Fine. Look on the screen. Look at the text we are using. Slide number 18. Read the instruction on the numeric. Read what you can see there. Slide number 18 on numeric data types. Who can read for me? Point number 1.
Numeric variables can contain only numbers.
Point number 2.
These variables can be used in arithmetic operations.
Okay, so these variables can be used in arithmetic operations. Now, list the arithmetic operations you know. Who can tell me the arithmetic operations you know?
So plus.
Subtraction, multiplication.
Plus, multiplication,
Division.
Division,
Subtraction.
Addition, subtraction, right? Okay.
Multiplication.
Can you add two phone numbers?
No.
Can you subtract one phone number from the other?
No. It's not
Can you
possible.
multiply one phone number by the other?
Now.
Our
No,
phone numbers multiply.
no,
No, please.
Our phone numbers divided.
No,
No,
please.
no.
So you see where you are confused.
Yes, please.
You don't store phone numbers in numeric data types. You store them
Okay.
as what? Text. Look down there. Let's go to character. Who can read what you can see on the character? First point on the character.
character variables can contain any combination of letters, numbers, and special characters.
So you see, any combination of letters, numbers, and special characters. So phone numbers are just combination of numbers. I hope you are getting me.
Yes, sir.
Now go to the next point. Point 2.
These variables cannot be used for calculation.
For what?
For calculation.
For calculation. For calculation.
Yes,
So you
sir.
cannot perform arithmetic operations on character variables. So phone numbers are a group of numbers, all right. But you cannot perform, you can't perform arithmetic operation on phone numbers. So if you are declaring their variables, you don't use numeric data types. I hope you are getting me.
Yes, sir.
Are you all here with me?
Yes, sir.
Yes, sir.
My guys, are you here?
Yes, sir. We
They
are here,
come
sir.
as a set of numbers, but not numbers that represent quantity. Phone numbers don't represent a quantity. Yes, Desmond.
All right,
I
sir.
saw your
So
hands up.
yes, I was asking since the character can take the numbers and let's say the phone numbers, you only need to write the numbers. So if you use character, maybe the user can also input other characters in addition to the phone number. So how will you go about that as well?
Okay, so you can validate that the variable to make sure that for that phone number there should not be any text in it. I hope you are getting it.
Yes, sir.
You can validate it. Another thing is that you see the whole idea is this: since the field, the variable that is going to contain that number we are terming as phone number, you cannot perform arithmetic calculation on. That is the idea. If you declare the number as a numeric number, then the idea is that later on somebody may try to perform arithmetic operations on, may try to multiply. So, for example, that is why if you look at how we measure our phone number, we start with 0. 0244717377. Can you call it in terms of numbers? If the first 3 numbers, in school we were taught we have ones, tens, hundred, comma, thousand, 10,000, 100,000, comma, million. Do you remember those things? Do you remember those things?
Yes, sir.
Yes, sir.
Okay, so Ayam, please give me your phone number. Mention your phone number for me.
Okay, 024
024
178
178
3090
3790. So I'm writing it down.
3090 30.
024. Please say
Yeah.
024 178 what?
30.
Oh, please start again. Start again.
024
Uh-huh.
178
Uh-huh.
3090.
3090.
Yes, sir.
Okay. Yeah, please mention this as a number. A quantity number. A quantifiable number. A number that represents a quantity.
Please, the question is.
So I'm going to, as I mention it as a number that represents a quantity. For example, this is supposed to be 0 billion. This thing, I'm mentioning it for you.
Okay.
0 billion 241 million 783,090 Ghana cedis. Can you say your phone number? Can you mention your phone number like that?
No, sir.
So, because your phone number does not represent a quantity, it's just a series of numbers that we are using to identify a communication line, but not to perform arithmetic operation. That's the argument I'm making.
Okay.
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 So let's go on. Let's go on. So phone numbers are not arithmetic numbers.
Yeah, hello,
They
sir.
are not arithmetic numbers. They are
Hello, sir.
numbers. Are you here with me?
Yes, sir.
There are
Sounds
numbers that
okay.
are used to just identify a line of commutation. You cannot perform arithmetic operations on them. Therefore, if you are declaring them, be careful how you declare them. Okay, let's go on. Let's go on. Slide number 19.
Sir, please, someone wanted to ask a
So,
question.
yeah, please ask. Please ask. Feel free.
So with the numeric variable, it was
Yes.
stated that, so please, can you go back to the
Yes, I'm
that
there. Slide number 18.
it can
I'm there.
contain, it can contain only numbers, and also these variables can be used in arithmetic operations. But this also an option it has given to us. But you know when, so let's say, I don't know, we should have, how do I put it? When you put the phone number, when you use the numeric variable to declare a phone number, and with what they defined here, meaning the arithmetic is also an option, which clearly doesn't state that before you use the numeric variable, you should think of performing an arithmetic operation. I don't know if you are getting me.
Yeah, so normally when you create a numeric variable, okay, the idea is that this variable that you create, you may later on perform some operations on it, which is arithmetic. That is the idea. I hope you are getting me. So,
Yes,
for
sir.
example, if I'm creating a program to accept student fees, school fees, are you here with me? Once it is fees, the name of the variable is fees. Then the idea is that if it's fees, the student may pay part of the fees and may pay the rest later. Are you getting me? Are you here with me?
Yes, sir.
So if he may pay the rest later, then I will perform, going forward, we may perform an arithmetic operation on the fee. So fee paid, balance, or something. How do we find the balance fees? Oh, fees paid minus original fee charge minus fee paid is equals to balance. So in this case, we are performing arithmetic operation. That is the idea. Are you here with me?
Yes, sir.
So in that case, if you are declaring the variable, you don't declare the fees as well, a text variable or a character variable. You declare it as well, a numeric variable, because at the end of your mind, going into the future, somebody may perform some arithmetic operation on the fees. Another example is you are creating a program for a superstore. Then you know that there will be an amount that a customer must pay for product bought. There will be an amount, and that amount has to be calculated by the quantity of the product bought plus the prices charged. So in that case, your variable should come in a numeric value, because you know that you are going to charge, you are going to calculate the amount, the system is going to calculate the amount, which will be equal to the quantity of the product bought times the prices. Are you getting me? And once you know that there will be multiplication somewhere, then the variable you are creating should be numeric. Now, please, no, I said something else, you can repeat it. If you are creating a program, know that you are the god of your program. So you should think ahead of what can happen to the program. Anyway, we'll come to those things when we get there. Let's go. Any other question? Hello?
No, sir.
So when we talk about numeric variables, we are just indicating that yes, create the variables, but have at the back of your mind that those numeric variables or the variables variables with the numeric data types, you are going to perform arithmetic on. If you don't perform the arithmetic operation, then nothing happens. But if it gets to a point that that operations must be performed, then you must perform it. Okay, that is the idea about declaring these variables. But know that the computer system just accepts two main variables. If you look at slide number 19, you see a pseudocode. This is an example of a pseudocode, okay, that we saw. The pseudocode representing the memory space that we saw. So you see, begin numeric number 1, number 2. I'm not here to go into details, but then, so you see this slide number 70, you see the memory space there. Have you seen it? Can you see the slide?
Yes, sir. Yes, sir.
So that operation there is what is represented as a pseudocode on slide number 90. But let's go on. Now let's look at how to name variable. This one you can read it when you are learning. Okay. So we say when you are naming a variable, make sure that the first letter of the variable must indicate the type of data you are using. Now let me say this before. Let me go back to the data types before we go on. Please take note of this. Every programming language has its own set of data types. Do you hear what I mean?
Yes, sir.
Are you here with me?
Yes, sir.
Every programming language. So basically, we say we have two types of data types. We have the numeric and text or character. But it depends on the programming language you are using. Some of the data types are common across, some are specific. So it depends on the programming language you are using. So every programming language has its own set of data types. Right? So when we come there, when we start using the Flutter and then that programming language and we come there, you understand. Every programming language has its own set of data types and how to declare the variables. So for example, if you take C++ as a programming language, the numeric data types, we have integer, we have float. So we have int, we have float, we have int, we have float, we have double. These are the numeric data types. We have the values, there are various variants, but these are the main numeric data types. When you come to the text or character data type, we have char and then we have string. So these are the text data types. So it depends on the programming language you are using, and then the set of numeric data types, and then the set of what? Text data type. That's what I want to draw your attention to. Okay, let's go on. So if you are declaring a variable, then please, the first letter of the variable must indicate the type of data types you are using. The name of the variable should be clear to declare its purpose. If the variable is for fees, name it fees. If it is for age, name it age. If it is for first name, name it first name. If it is for an area of a rectangle, name it. If it is for length, whatever the name of the variable is, must have the purpose why you are using the variable. I hope you are getting me. A variable name cannot start with a number. So you cannot declare a variable and say that 9 first names. No, you cannot start a variable name with a number. So when I give you the slide, you can read through and see. Let's go on. Can we go on? Slide number 21. Can we go on? Are we there?
Yes, sir.
Yes, sir.
Can you see slide number 21?
Yes, sir.
Yes.
Okay, so let's go on. Now, after you've declared your variables, we say the computer accepts data. So the data is accepted into the variable. The next question is, how do you assign values into the variable? How do you make the computer accept data into the variable? How do you make the computer to accept data from the keyboard into the variable? And yet I want you to listen to me very well. There are two ways you can assign data to the variables. There are two ways. One, you can use the equal sign, one equal sign, which is called the direct assignment. That is the first way. I want you to listen. I will explain in what cases are you using which one. So you can use the direct assignment, which is the equal sign. I'll come there. If you go to slide number 22, you see the equal sign there. And then you can use what here I have termed as accept. Please. So you can use, I don't want to use the word accept, but I will explain. Let's use accept, but I will explain. You can use the accept statement. I will explain the difference between the two. So for now, let's maintain the word accept statement. I will explain. So these are the two ways you can assign values to variables. When you create your variables, for example, when we go to slide number 17, we've created variable number 1. There's 10, we put the number 10 into it. Variable number 2, 15 into it. If you want to assign the 10 and 15 to number 1 and number 2, then on slide number 21, we say you can use the direct assignment or what? The accept keyword. Let's start with the direct assignment. Slide number 22. The direct assignment is your equal sign. So if you want to use the equal sign to assign data into the variable, then the syntax is you bring your variable name, you bring the equal sign, and then you bring the value. So you declare your variable, then you bring the variable name. You call it what? Name value pair. Name is equals to value. So for example, on slide number 22, we've declared the following variable: n height, n age, n counter for numeric variables, c character, c code for character variable or text variable. Then we say n height is equals to 172. You see that we are using the equal sign there, the assignment operator there. N age is equals to 35. N counter is equals to 0. C code is XYZ. Now this is what it means. Put 172 into the variable whose name is what? N height. Put 35 into the variable whose name is what? N age. Put 0 into the variable whose name is N counter, and put XYZ into the variable whose name is what? C code. Now notice something. Please look at, are you here with me? Are you here with me?
Yes, sir.
Yes, sir.
Look at slide number 22. The variable names are all using equal sign, but there is a difference somewhere. Who can identify the difference? Look at it and tell me. N height 172, N age 35, N counter 0, C code XYZ. They are all using the equal sign, the direct assignment. But there's a difference somewhere. Who can tell me the difference? And why?
So the C code with
The
the
C code,
XYZ, with the XYZ, it has this quotation mark.
Yes. Why? Why?
Because it's a character.
Because it's a character. Clap for yourselves. Because it is a character. So if you declare a character variable, a text variable, in all the programming languages, and you are using the assignment operator, the equal sign. The equal sign is also used in all the programming languages. Then you must put the text you are inputting into the variable into inverted commas, into quotes. Height 172, the data type is what? Numeric. So this is a numeric data, it's an integer. So it is not in quote. The 172 is not in inverted commas, it's not in quote. Age 35, the variable name is what? N age, numeric age. So numeric means that it is an integer. So the value 35 is not in inverted commas. N counter, the value is 0. 0 is N counter, N numeric, which means that 0, you are looking at the number 0, not O. so it is not in code. But the C code is in the character C. So you put the string into what? Double inverted commas. If you declare a variable and the data type is string, and you are going to put a group of characters into the value, and you are using the equal sign, you put the value into what? Double inverted commas, quote. Are we okay?
Yes, sir.
Any question here? Because I'm going. Any question? If no question, let's go. Slide number 23. So you see examples there. Okay, let's go on. So that is with what? Variables. Any question on variables before I go to what? Operators. Remember variables, if you want to declare a variable, you should use the data type and then you should use what? The variable name. And remember, data types depend on the programming language you are using. You may have several data types of different type of data types. So depending on what you want the variable to contain and then the data type that you use. Any question on variables? I'm going to operators. Any question on variables? Any question? I should mention your names again. Any question on variables?
No questions.
No question. Okay, so let's go on. Let's go on there. Operators. Can you see slide number 24?
Yes, sir.
So we say operators are used for some predefined operation. What do you think are operators? I'm talking too much. I want you to come in. What do you think are operators? Who can tell me what operators are? Who has an idea?
So please, they are used in making decisions like the end or others of the addition, subtraction.
Okay, you have an idea. That is good. That is good. You have an idea. But let's go back to our cooking, right? Let's go back to our cooking. Ariam,
Sir.
give her the type of cookings that you have.
Types of.
Yeah, woman, so you cook a lot. Cooking.
Okay, so boiling, baking.
Boiling. Take your time. Take your time.
Okay.
Boiling. Then we have what? Baking.
Baking. Yeah.
Then we have what?
Steaming.
Steaming.
Steamed.
Then we have what?
Grilling.
Drilling. Hey, LGBT down.
Grilling.
Okay.
Grill.
Drilling. And then we have what? Smoking, right?
Roasting.
Roasting.
Yes.
Roasting. And then we have what? You name them.
Frying.
Frying. Okay. I mentioned smoking. You have smoking. If you go to the beach side, you go to where they smoke the amani and the roasting. I hope you are getting me. You know amani?
Yeah.
Yeah.
Ah, yes.
And those fish, they are smoked. Okay. So we are smoking.
Okay.
Okay. So these are the different type of cooking that we have. Are they the same? The method, boiling and baking, are they the same method?
No, sir.
Steaming and baking, are they the same?
No, sir.
Roasting and frying, are they the same?
No, sir.
But they are all types of cooking, right?
Yes, sir.
Okay. The computer accepts data, processes the data. Now, how does the computer process data? The computer processes data by using operators. I hope you are getting me.
Yes, sir.
So it is the operators that define what the computer should do. The arithmetic and logical unit, the processor, what it should do on the data that you have accepted to the variables. Guys, are you here with me? Can you all hear me?
Yes, sir.
Yes, sir.
So if you want to add a computer to process data into what? Information, then you use operators to tell the computer the type of process you want. Just like we have the type of cooking, we have type of processes. Then we have different type of process. And it is the operators that tell the processor the type of processing that it wants. That's why the book defines operators as tools for predefined operations. The operations just mean that what? Processes. What type of processing do you want on the data? Is it cooking? What type of cooking? Is it boiling? Is it baking? Is this steaming? Is this dreaming? Is this drilling? Is this roasting? Is this frying? The type of process, the type of operation that you want to be carried on the data you've accepted into the variable is given by operators. Now, for programmers, we use different type of operators, but these are the three that is always used. On slide number 24, you see I've listed some three type of operators. So we have the arithmetic operators, we have the relational operators, and then we have the logical operators. Let's see if we can quickly go through them. We have the arithmetic operators, we have the relational operators, and then we have the logical operators. So these are the arithmetic operators, the symbols. Okay, arithmetic operators are symbols. Please let me say this. Operators are symbols that define the type of operation that should be carried on data, accepted data. So arithmetic operators, you have the symbols there. You can see them. Slide number 25. You have the asterisk or the star for multiplication. So in programming, we don't use the X for multiply. We use the asterisk for multiplication or the star you can see there. And then we have the front slash, the slash for division. And then we have the plus sign for addition, the cross for addition. We have the dash for what? Subtraction. And then we have the modulo, the percentage sign for modulo, finding the remainder of something. When two numbers divide and you want the remainder, then you use what? The modulo. So for programming, we have only 5 arithmetic operators. No matter how complex a mathematical formula is, we are using only these 5. The plus, the minus, the multiply, the divide, and then the modulo. And they go in this way. The first one with the higher precedence is what? Multiplication, then division, then modulo, then addition, and then subtraction. That is the precedence. So if you have an operation or a process, an operation that contains more than one of these symbols, then the first one that will be executed first is what? Multiplication, followed by division, then the modulo. The modulo, the percentage sign is used for modulo. Find the remainder. If one number divides the other, there will be a remainder. Then we have the addition, and then we have the subtraction. Any question on the arithmetic operation? Any question? Any question? Guys, ask me questions. So. Any question on the arithmetic operation? Yes.
Sir, please, the third one, can you please take it again?
The one with the percentage sign.
Yes, sir.
So that one is used to find a remainder when one number divides the other. For example, if you divide 25 by 4, what will be the remainder?
25 by 4. Sir, please, no, 1.
Why? How did you get the 1?
4. So 25.
4 goes to 25 how many times? 6 times, right?
6 times.
4
yes.
64, right?
Yes.
The remainder 1. Okay, so that if you don't want to do this division and find the remainder, this is the symbol you use and it will give you 1 straight. Are you okay? So if you want to find the remainder if one number divides the other. For example, if you are dividing 100 by 6, what will be the remainder? Then you use this. You create a variable to contain the 100. You create another variable to contain what? The 6. I hope you are getting it. You create another variable to contain the answer. Then you say what? Let's say number 1 contains 100. Number 2 contains 6. So remember, the result is equal to number 1, the percentage, and number 2. It will put the value into the remainder. Are you okay?
Yes, sir.
Or you want me to show you a pseudo code? Okay. Okay, you let's go on. I'll code later on and then see when you are. So the percentage sign is used for finding the remainder if one number divides the other. Okay. Are you okay?
Yes, sir. Thank you.
Okay, let's go. Slide number 26. Relational operators. Relational operators are used to compare two values. They are used to compare and determine which one, if they are equal or not, or which one is greater than which one. So relational operators are used to tell the ratio between two variables or the ratio between a variable and a constant. So you use another name for relational operators is what? Comparison operators. You want to compare two numbers, two values, and then you determine which one is greater than the other. Are they the same? Are they not the same? I hope you are getting me. And there are 6 of them. So we have, please take note here. I made a mistake. I should have changed it. You see the equal sign there? Sign number 26. Have you seen the equal sign there?
Yes, sir.
It should be double equal sign, not one. In programming, one equal sign is not the same as the double equal sign. I will explain. So here, it should be double equal sign. So you say there are 6 relational operators. The first one, the first equal sign there, should be what? Double. The same equal sign repeated again, comma. Then we have the greater than sign, the less than sign, the not equal to sign, the greater than or equal to, the less than or equal to. So the equal to, you can see there should be 2 of the equal sign. One equal sign is an assignment operator. Here we are talking about relational operators. We are using them to compare numbers. So there are 2 of them. Next week I'll demonstrate for you to see. Are we okay? Any question here? The rest you know the greater than sign, right? Hello?
Oh, sir. Yes, please.
You know the greater than sign?
Yes,
Yes.
sir.
You know the less than sign?
Yes.
Yes.
You know the not equal to sign? You see it. It is exclamation sign and the what? The equal sign.
Okay, yeah.
That is the not equal to. In mathematics, they'll draw the equal sign, then they'll put a slash across it. Do you remember?
Yeah.
But here it's not that. You don't do that in programming. In programming, it is the exclamation sign and then the dash sign. Anytime you see exclamation sign in programming, it means you are talking about not equal to something. And then the equal sign should be double. The double equal sign for comparison. So these are the relational operators. They are used to compare values in variables, to compare which one is greater, which one is not, which one is, are they equal, and all those things. Okay. And then we have the logical operators. The logical operators are 3, like I think Hima said it, or Stephen. There are 3. We have the and operator, the or, and then we have the not. Please, here, I don't know. Let me demonstrate. Let me show you the and, the or, and the not. Just a minute. Can you see my screen?
Yes, sir.
Can you see my screen?
Yes, sir.
Yes, sir.
Yes.
I am opening Microsoft Word. Can you see it?
No, not yet.
Not yet. Okay, so let me do this. I'll capture you back. Just give me some few minutes. I'll be with you.
Okay, sir.
So we have the AND operator. This is AND. This is equals to AND. The AND operator. Then we have the OR. And then we have the logical NOT. Yeah, I'll be with you in a minute. Don't worry. I'm typing some things.
Hello, sir.
Yes, I'll be with you. Yes,
Yes, I have a
talk,
question.
talk. Please talk.
Yes. So the operators, the logical operators, is there a
Yes.
must that they should be in caps?
No, I'm coming. That's why I'm coming. I'll show you something. Just hold on, okay?
Okay, all right. Thank you.
I know you're asking the question. That's why I'm coming. They are actually symbols, and I'm typing the symbols to show you. They are not in text like the way you see them.
Okay.
When you are programming, you don't use the text AND. I hope you are getting me. You use symbols. That's where I'm coming to. So relax.
Okay.
I'll show you.
Thank you.
Just give us a few minutes. Okay. Please, can you see the screen now? I've shared it. Can you see it?
Yes, sir.
Can you see it? I've typed logical operators. Can you see it?
Yes, sir.
Yes.
And you see the symbols there. The double, what do you call it? End sign. Have you seen it?
Yes.
It's for the AND operator. So like I said, we don't use the AND. We don't use the AND. We use what? This double symbol. Have you seen it? The end sign there, double of them. And then the double, this is not slash, we call it the pipe. Straight lines. Double straight vertical lines, like you can see. If you look on the keyboard, if you look on the standard keyboard, they are with the backslash. They are with the slash. Okay? The front and the backslash, they have this pipe on top of them. Okay? The double is for the OR, and then the exclamation sign is for the NOT. Are we okay? These are the symbols for these operators. So when we are programming, we don't use the AND. We don't use the OR. We don't use the NOT. I hope you are getting me. We use these symbols. Are we okay?
Yeah.
Yes, sir.
Are you there with me?
Yes, sir.
Yes, sir.
These are the symbols we use when we are programming. And then when we come to the relational operators, we have the greater than sign, we have the less than sign, we have the greater than or equals to, we have the less than or equal to, we have the not equal to, and then we have the double equal to. Have you seen what I mean? Down there.
Yeah.
The double equal sign.
Yes, sir.
Okay, this one is different from the one equal sign. The one equal sign is called assignment operator. This one is called relational operator. Assignment, the one equal sign is used to assign a value to a variable. This one is used to compare two variables, values inside two variables. They are not the same. So, for example, do you have your bag with you?
Pardon?
You have your handbag with you.
Yes, sir.
Okay. Do you have a pen with you?
Yes, sir.
Put the pen into the handbag.
Okay, sir.
What are you doing? You are assigning the pen into the handbag. The handbag is a variable, it's a container, and you are putting something into it. You are assigning the pen into the handbag. So you use the one equal sign. Are you here with me?
Yes, sir.
Now, so you have put the pen into the handbag, right?
Yes, sir.
What and what is in the handbag? Why are you laughing? I'm teaching.
The tissue.
Tissue. So now,
Yes.
what are we doing? We are looking at the content. We are comparing the handbag. If we can see what? Tissue. Go on. What again?
Peas.
Pins.
Yes,
Go
sir.
on. And then the rest. You don't worry. I know what is there. You don't go and mention something that the boys will laugh at you. Okay. So if you want to compare what is inside two variables, you use the double equal sign. But if you want to assign a value into a variable, then you use the one equal sign. Are you okay?
Yes, sir.
Yes,
Okay,
sir.
we get the small. Let's go on. Okay, so please note that, for example, if you want to compare, number 1 is 7, right? Look on the screen, slide number 23. We've created the variable and we put number 1 there, and then we put number 2 there. Normally, we use the logical operators to compare, to combine conditions and then compare, to combine conditions and then compare. So we'll look at example when it comes to the real program. Now let's move to the next thing you must know. Our time is always up, so let me speed up small and then. The next thing you must know about programming. So we said that if you are creating a program, you need to take note of what, how to represent your algorithms, your logics through flowchart and pseudocode. Then we talk about variables, we talk about data types, we talk about operators. Now, the next thing you must know about program is sometimes you ask the computer to execute a program or a part of a program by evaluating a condition, which here I'm stating as what? Representing decisions. You want the computer to represent decision, to select, we call it selections. Or the computer to make choices. So you can program the computer and say that I have this list of items, choose one of them. So the computer make choices. Just like you also have your choices to make. You can write a program and add the program to take an item from the list of items, or to take an item, choose between two items. That one, you use what you call decision construct. If you want the computer to select among a list of items, or to select from two lists of item alternatives, you use what? Decision construct. Now, I think I will end here for today, and then hopefully next week, if we can, because I think you are tired, or you want me to continue?
Sir, we are
Yes,
tired.
sir, we are tired though.
Yeah, so when you have got it, I can see so, because we spent the 2 hours. So next week when we come, we will start from where we've gotten to, representing decisions, okay?
Okay.
So we'll look at representing decisions, and then we'll look at representing repetitions, then we'll continue with what you are supposed to do next week. Are we okay?
Yes, sir.
Yes, sir.
I am still not able, I'm talking to them, they've not created my login. Steven, are you there? Hello, Steven. Okay. They've not created my login so that I can start putting items on the LMS. I'll make sure that. Hello, Steve, are you there?
Yes, please, I'm here.
This Monday, call me and remind me so that I can get the logins for the LMS created, my account created, so I can start putting this presentation and the slides and whatever I have on the LMS for you to download them. Okay?
Okay.
The school have not yet given it to me, but by next week it will be ready. Please, any question for me before we log out? Any question? For all that you've done so far? Some of you have left, right?
I have a question.
We are here.
Yeah. Okay, ask me your question. Please, who is talking?
It's Steven.
Yeah, Brother Steven, talk. I'm listening.
Please, which programming language are we going to learn?
So we are going to learn what is called the Dart programming language, DART.
Oh, okay.
The Dart programming language. And the framework you are going to use is the Flutter framework. FULUTTER. Flutter. And then we are going to use the Visual Studio to do our coding. Studio, okay? So next week I'll give you the setup and I'll teach you how to do the installations, okay?
Okay.
So next week we are doing the installation for the framework programming language we are using. Don't worry, I will do that next week. After the decision comes out, then I'll post a video there to guide you through the installation process.
Okay.
So don't worry, everything will be sorted out. Yes, any question for me? Elvis. Elvis.
Sir.
Any question?
No question, sir.
Emmanuel.
Yes, sir.
Any question?
No, please.
George.
No question, sir.
Okay. Desmond.
Sir, please, no question.
Prince.
No questions, sir.
Maybe some question. No, you can't say. Adams had issues. So, what the name? Justice. Prince. Okay. So, guys, I'll put some items on the LMS for you next week. Then you can download and start reading. Thank you for coming. God richly bless you. We'll meet next week. Bye-bye.
Bye-bye.
Bye.
God bless you too.
You too.
Bye.